Hello, I'm Ali Nabhan Abu Bakr from UV Digital Systems, and here is my project. It's called AI Practicer, a Photoshop UXP plugin that helps artists build a daily practice habit using short-timed drawing drills. Instead of generating art like usual, it focuses on practice. You draw whatever the exercise asks of you and submit for results and feedback. Everything is local, meaning that the panel runs inside Photoshop, your progress is stored locally, and the AI check is done through a local Flask service. This plugin exists to help artists consistently practice fundamental skills using microlearning in a manner that doesn't require them to find time to actively practice using third-party practicing services that are often unrelated to their digital arts medium or take precious time needed for commissions and deadlines. My aim was to build an easy-to-use plugin with immediate feedback, a history of previous attempts to measure improvement, and a focus on specifically digital art. For a minimum viable product, I focused on the core loop and keeping it usable and stable. Draw history settings all in one panel, starting with a locally hosted AI endpoint, local storage of settings and history. Anything like cloud sync, accounts, background reminders when Photoshop is closed, or advanced AI critique is future work. The system architecture is simple, with the UXP panel rendering the UI and capturing the sketch. The local Flask API receives the sketch, gives it to the ResNet model, and returns a prediction output. The panel takes that and adapts it into a consistent internal format and stores the results locally to view in history. The diagram shows visually this process with some extras such as how the panel reads prompts and where settings are kept. This project uses JSON for file storage and not a database. The key files are history.json to store sessions as raws, prefs.json to store preferences such as frequency of reminders and other settings. Finally, a prompts.json to store exercise prompts for you to do when asked. There are no foreign keys if you are confused by the diagram, just value associations. Start off after opening the plugin panel, the user lands on the Draw tab. Pressing the Start button immediately allows you to use the plugin by selecting an enabled practice type by your preferences. It also clears the canvas, starts a timer that lasts 3 minutes by default, and enables the Submit button. The other way to activate the plugin is by automatically waiting for one of the times which activate the panel and asks you to do a specific exercise. The flowchart to the right repeats these steps in a visual format. On submission or when the timer hits 0, the panel captures the canvas as a PNG and posts it to localhost with a 10-second timeout. If it succeeds, the response is normalized and shown. If it fails, the UI shows a message saying why and logs the attempt. Then history is saved and re-rendered. Implementation highlights are about robustness and staying inside the workflow, about how everything is in a single panel UX, how PNG and multi-part post are used for compatibility, how local-only guardrails are used with the default 127001 as an endpoint, about how atomic JSON writing is used to reduce corruptions risk, and paginated, and how history is paginated for readability. If you want a quick code rundown, the UI is in index.html. The core state and timer are in AI slash practicer.js. The only current Canvas tools are a pen and an eraser. The API client posts into slash predict, and the storage writes to history, prefs, and prompts.json files. For testing, I verified the critical use cases, such as submit paths using PNG serialization and post, timeout handling, feedback normalization and rendering, the persistence of the history, tab content, and pagination. The full report will show executed versus planned tests clearly. Current limitations are about how there are no background reminders when Photoshop or the UXP panel is closed, about how there is no dirty state gating, and about how the local AI service must be running to send and receive feedback, although failures from the AI not running are handled by the timeout error path. Mitigations include local-only endpoints for privacy, errors that say the reason why something didn't work, and an option to retry submissions. Next steps include adding dirty state gating, which means to only allow submission once you have drawn something on the canvas, expanding the exercises more, improving accessibility, and hosting the model online for anyone to use the plugin. I will now demonstrate the plugin in action. You first start the plugin using Photoshop and UXP tools. You can erase as well if you toggle it. You can see the reset button working. We first need to run the AI locally first. Doodling is used as an example for the MVP to show that the plugin works. It was not intended to be important or the final product. Because different people draw different things differently, it's more difficult for the AI to identify what is what. And doodling is not exactly a fundamental skill worth practicing, such as shading or drawing a circle as perfectly as humanly possible. The times 1, 2, 3, hopefully in the future release you can increase the amount of times that you can practice daily or decrease it. Along with being able to edit how much time is left for an exercise. ES. If you press draw, it will be N/A. This is how you will normally have the plugin activated, out of sight, but within reach. If you so wish, you can export the CSV file and also the pagination. Only 5 of them are visible at a time. You will have to go to the next page to view the other things. You can even delete history if you so wish. You can also clear the history entirely all at once. This is for people using the UXP tools. Here you can see index.html, which contains the complete UI structure with the 3 main tabs: draw, history, and settings. You can see style.css, which is a comprehensive styling thing using CSS custom properties for the theming. Here you can see the index.js, which is the UXP entry point that loads the panel itself, and here is the core application logic. So I actually used the IEFE because UXP doesn't support ES6 modules in the panel HTML scripts. Then this allows me to encapsulate all the UI logic without polluting the global namespace. It ensures the code runs immediately when the HTML loads, which is crucial for the plugin to run. I implemented a 28x28 grid system that tracks the drawing strokes in real time. This is more efficient than reading the canvas pixels repeatedly. I selected 28x28 because this matches the input size expected by the model, and it's a good standard size for MNIST style digit recognition models. It provides a good balance in the end. For state management, I used a centralized state object to manage the things, such as user preferences, reminder scheduling, and history entries, and the timer cooldown. For storage, I used localhost storage for history and settings and preferences. And I used the UXP file system API for the CSV exporting, because this is fast and it doesn't require input output for such simple data. File input output. For the AI integration, I used the predict pixels 127 thing, and I sent the 28x pixel grid as a JSON file, and it receives the prediction with confidence score and label. For error handling, I said things like, if the AI server is unavailable, the plugin still records the session. and if it shows an offline status in the history. I used localhost for privacy reasons, and it's speedy compared to online services, and there is no monetary cost, and it allows people to use and train special models, AI models, that can read images like this. And for this is this here is the model itself. You must go here and then run app.py to start the AI, the local AI. And manifest.json is used by UXP to run the plugin.